man who measured the speed of light in 1845 was an absolute genius. He was the French physicist Fischer, and look how he did it. This is the key component of the experiment, a special gear. Notice how every tooth and every gap in the gear is the same width. What's the point of this? I'll tell you in a minute. First, we also need a light source, either a light bulb or a candle, as long as it emits a beam of light. Next, we put a semi-reflective mirror in front of the light. This type of mirror allows some of the light to pass through and some of the light to be reflected. We tilt the semi-reflective mirror slightly. Finally, we put a regular mirror on the opposite side of the gear, and we are ready to start the experiment. When we turn on the light source, the light will first pass through the semi-reflective mirror and then through the gap in the wheel to the mirror on the opposite side. The mirror on the opposite side will reflect the light back, again through the gap in the wheel, and finally be reflected back to our eyes by the semi-reflective mirror. This way, we can see the light. But what if we make the wheel spin? You'll notice that the light you see will keep flickering. Why? Because when the wheel turns, sometimes the teeth block the light, and sometimes the gaps let the light through. What if we make the gears turn faster? You'll realize that there's a moment when you can't see any more light. Why is that? It turns out that when the gears are spinning fast enough, the light is completely obscured by the teeth of the gears as it passes back and forth through them. That is, when the light is emitted from the right, it can reach the mirror on the left through the gap, but when it returns from the left, it happens to hit the teeth. In this way, we can't see any light at all. This phenomenon is actually the key that Fischer used to measure the speed of light. Knowing the speed at which the gear turns and the distance between the gear and the mirror, the speed of light can be calculated using a simple formula. According to the Fedelier-1 formula, speed equals distance divided by time. Distance is the distance from the gear to the mirror multiplied by 2, and time is the time it takes the gear to turn one gap. The gear used by Fedel has 720 teeth and 720 gaps, and makes 13 revolutions per second. So the time it takes the gear to turn one gap is 1/18,720th of a second. The distance between the gear and the mirror is 8,000 meters, so the round trip is 16,000 meters, which, when substituted into the formula, gives the speed of light as 299,520 kilometers per second. This is not far from the speed of light that we know now. It is hard to imagine that more than 170 years ago, Fischer was able to measure the speed of light with only such a simple experiment.